Have you ever played a game involving dice and thought, why didn't I get a 6? Spoiler, it's quantum mechanics. I think if you have a little idea about quantum mechanics, you probably have heard about Schrödinger, Bohr, or even Dirac. However, I am sure most of you haven't heard about this guy here, Hugh Everett. We'll get to him later in this video. First, let's start with the most famous interpretation of quantum mechanics, that is the Copenhagen interpretation. And this became world famous because of this, the Solvay Conference of October 1927. I won't go into too much details of this interpretation here as it is way beyond the scope of this video. Just remember that quantum particles like electrons can be in two or more places or states at once until a measurement is made. To give an example, let us go through one of the most well-known thought experiments in history, the Schrödinger's cat experiment. It goes like this. Let's say we put a cat in a box, and in the box we also keep a piece of radioactive element which has a 50% chance of decaying. We also keep a detector which releases a poison once it detects the decay of the radioactive element. Since each atom of the radioactive element is a quantum particle, it is in a state of superposition of being both decayed and not decayed at the same time. But since the life of the cat depends on it, we say that the cat is entangled with the radioactive atoms, thus also being in a superposition of being dead and alive at the same time, until we open the box. Quantum mechanics is really messed up. However, there is a way around this. Remember this guy? He proposed another interpretation of quantum mechanics. It is called the many worlds interpretation. Now let's view the Schrödinger's cat experiment, but this time through the eyes of the many worlds interpretation. Here, we are performing what is known as a quantum experiment, an experiment with many different outcomes. If we oversimplify a bit, this is practically the same experiment as rolling a die. According to this interpretation, in a quantum experiment, all the outcomes take place at once. However, we can observe only one of them because all those other alternative outcomes occurred in a different parallel universe. Thus, during an experiment, the entire universe branches itself into as many universes as the number of possible outcomes of the experiment. Thus, in the Schrödinger's cat experiment, if the cat is alive in this universe, there exists a universe in which the cat must be dead. There also exists a universe in which you always roll a 6 in a die. Thus, whenever you take a decision or face a dilemma or take a choice, the entire universe splits. This implies that there is an infinite number of parallel universes, a multiverse. So now to the final question. Which one of these interpretations is correct? Which one should you believe? The answer is the one you choose to believe, because we still don't know. And according to many scientists, we perhaps will never win.